Here we're looking at circles and arcs. This is 10-6. So two central angles, looking at the picture over here. We've got one central angle would be angle DCB. And the other one would be angle ACB. A major arc is an arc that is over 180 degrees. So we usually use that, name that with a little arc symbol. And then we use 3 letters to name a major arc to show that we're acknowledging that it's over 180 degrees. So something like arc ADB would be a major arc, or and we could name one BDA, would be another example of a major arc. Minor arcs are less than 180, so we usually use just 2 letters to name a minor arc. Something like AB or DB would be BD would be minor arcs. A semicircle that contains B would be arc ABD, and it includes half of the circle. So the measure of a minor arc is equal to the measure of its corresponding central angle. The central angle is measured from the center of the circle. The measure of the arc is the measure of the related minor arc subtracted from 360. So that's the remainder of the circle as you see in the picture here. So from here over to here, 360 minus 50 would be 310 to get that measure of that central arc RQT. Let's find the measures of some of these arcs here. We've got measure of arc PR. So PR is going from here to here, or you could go the other direction as well, but it's a 180 degree arc. Measure of arc RS is 60 degrees. Measure of arc PRQ. PRQ is going in this direction. We know it goes this way because it's got to include R and then around to Q. That's everything but 40. So you go 360 minus 40, which gives us 320 degrees. And then arc PQR. So PQR goes this way, PQR. And that arc is 180 degrees as well. All right, the circumference of a circle is 2 pi r, or if you want to replace twice the radius, if you look at the 2 and the r, twice the radius is the same as a single diameter. The number pi is irrational. What does it mean? Well, the idea behind pi is that it's how many radii of a given circle it would take to go around the circle. So that number of approximately 3.14 tells us that it takes just over 3 radii of an individual circle to get around the circle. So here we have an arc length formula. If you know the measure of the arc, right here, measure of the arc, and from the central angle, so say you know where measure of the central angle is maybe 60 degrees, which is going to correspond to the measure of the arc as well. You can take the measure of the arc, 60 degrees over 360 times the circumference of the circle. So it's another way of saying just, but the arc length of a circle is really just some fraction of the entire circumference, 2 pi r. So the way we set this up is if we know the radius to be 5 centimeters, we know the measure of the arc to be 36, we have 36 degrees over 360 degrees times 2 pi times 5. Just plugging it into the formula for length of a given arc. 36 over 360, we can reduce that to 1/10. And 2 pi times 5 is 10 pi, so I've got 1/10 of 10 pi, which gives us an arc length of just 2 pi centimeters. This one over here, we've got a radius of 7. We know from here to here is 100. Right here, put that in there. So we've got an arc, measure of the arc is 100 degrees right here. The radius is 7. So I mean the radius here or here is also 7. So we've got 100 over 360, so 100 out of the 360 degrees times 2 pi times the radius of 7. So 100 over 360, we could reduce that down, 10 over 36, even more, 5 over 18. So we got 5 over 18 times 14 pi. Do some more simplifying here. The 14 and the 18 have a 2 in common. That's a 9 and a 7. So I've got 35 pi over 9 meters in this case. So just plug it in. Formula, it's some fraction of 2 pi r to get that arc length. All right, we got a little application here. It says the track has lanes that are 1.125 meters wide. Each end is 180 degrees, 180 degree arc with a radius of 29 meters to the first lane. So radius right here of 29. Same thing over here, you got a little half circle. You could put those two together to make a whole circle. 29 meters to the first lane. If the straightaways are 108.9, the straightaways from here all the way over to here. What is the distance around lane 1? So lane 1 is really made up of 2 of those 108.9s. So we have 2 of the 108.9 meter straightaways plus 1 circle. If you take this half circle with this half circle, you have 1 circle with radius 29, so 2 pi times 29, and that's going to give you the distance around lane 1. So we go to our calculator here. We've got 2 times 108.9 plus 2 second pi and then 29, and that gives us about 400 meters, which is what we knew it to be. That's around the innermost lane, lane number 1. So about 400 meters, pretty close to 400 meters right there. So how much farther do we go if we run around the second lane? If you were to go around this one, we've got 2 straightaways here and here, but we've got slightly larger circles. The radius of this little circle from here to here is 29 plus 1.25, or radius equals 30.25. Because each lane is 1.25 meters wide. So we've got 2 times 108.9 plus 2 pi times 30.25. Let's see how much farther we have to run if we're in the second lane. And you'll see why they staggered them. So going back to the calculator, you can do second enter, recall that previous line. Just go change this radius to a 30.25. And we end up going about 407.9 meters. 407.9 meters. So that's why we'd set up a stagger of about a 7.9 meter lead on lane 2 and do the calculations to figure out the length you would run around lane 3 and 4 and so on as well. So interesting problem relates to our track. Example 4, a tire has a rim diameter of 17 inches. So a rim diameter of 17 inches. So here's the rim diameter of 17. The sidewall width of the tire is 4.33. So that's 4.33, just the sidewall width of one piece there. How many revolutions will the tire make traveling 100 feet? So let's figure out here what we've got going on for the radius, first of all. So radius is going to be just half of this, which is 8.5 plus the 4.33. That gives me 12.83 inch radius. Okay, or if you want to think of it in terms of diameter, you could add another 4.33 over here, or double that value, but we end up with 17.8. That's 25.66 inch diameter. And so to figure out the circumference of this thing, we've got circumference equals, let's use pi times diameter just for fun. So we calculated that diameter to be 25.66. So we've got 25, or pi times 25.66. Let's see, for one full turn, give us our inches for one full turn. So on our calculator, pi times 25.66. So we've got second pi times 25.66 gives us about 80.6 inches. So 80.6 inches is one revolution. So we have 80 point. So that 80.6 inches is one revolution. So we want to know how many times it's going to turn to go 100 feet. Let's see, 100 feet at 12 inches per 1 foot gives us 1,200 inches. And so we just need to see how many times that 80.6 will go into the 1,200, and that'll give us our number of revolutions. We have 1,200 inches divided by 80.6 inches, and that's going to give us, inches will cancel out, just revolutions. So 1,200 divided by 80.6, we got 1,200 divided by 80.6. So it looks like almost 15 revolutions, so 14.9, almost 15 revolutions. We'll go with about 15 revolutions to go the 100 feet. So those are some applications there in examples 3 and 4 of the arc length of a circle. Pretty useful to know. Remember, our formula is just fraction of the circle times 2 pi r. A full circumference of the circle is 2 pi r, or pi times d. Hope this helps. Thanks for watching.